So class, unfortunately, for some reason, sometimes when I make videos, um, the volume, the audio is not recording. So I just realized that my last video numbers, the questions 5 and 8, did not record. So I'm going to go over these notes one more time in terms of just keep providing the audio. Um, in number 5, we were given a trapezoid. A trapezoid, the area of a trapezoid is this formula right here, right? So just hopefully you have this down, but it's base 1 plus base 2 divided by 2. You always add the two bases. You divide it by 2, which essentially means to average the two, and you multiply by the height of the trapezoid. Okay, so I just followed the directions and I just wrote down what they told me. The base of 15 and 11 is right here, and the height is 4. So I could calculate the area of the trapezoid, no problem. Letter B, and by the way, the area I got was 52 inches for 5A. Letter B said, can you draw a trapezoid that has the same area but has different dimensions? Well, of course you can, right? I just gave you an example right here where I just made the bases very, very wide, but I made the height maybe 2 times, uh, like I divided the height by 2. So, of course, the trapezoid can still be calculated with the same area. Just adjust the dimensions, okay? So then letter C said to sketch trapezoid with the same height, but with but with bases that are multiplied by a scale factor of 5 over 2. And we know that 5 over 2 is kind of like it's the same thing as 2.5. So all I had to do was take my bases, my 11 and my 15, and I simply just multiplied both of these numbers by 2.5 to get these respective numbers. The height was still 4, and uh, I was able to get the new area, right? You want to try this again. So if you haven't calculated yet, I highly recommend that you pause and you calculate this yourself. Um, but what I just did is I added 27.5 with 37.5 right here. I divided by 2 because that's the portion of the formula that you have to remember. And then I still multiplied by the height of 4. So this is my work, and my area is 130. Okay. So let's go to the next question, which I spent a lot of time on, and I'm just going to review one more time. We've seen problems like this where they ask us what is the area of the walk. The first thing I want to remind us with is that the area of a circle is always pi r squared. In order to count the area of the walkway, you're going to first have to calculate the total area of the entire thing, the entire circle. You subtract the area of the pool, which is the inner circle. And if you take the entire circle and subtract the inner circle, you will get the onion ring border area. We call this the area of the walk. It's very, very important that you use the correct radius values. So notice that my area of the pool has a radius of 15, and then the area of the entire circle, which is an extended 5 feet from the original circle, that means that I have a radius of 20. Okay, class? So really, this is not that difficult once you have both the radiuses down and you just know, okay, I'm going to plug it into the formula for the area of a circle, and I got 1256 for the total area, and I also got 706.5 for the area of the pool. Okay, obviously you then subtract the two and you get 549.5. That's how you handle this circle within a circle question. The area of the deck is 549.5. So if Nico adds the 5-foot deck around the pool, what percent of increase of space will this be? So in order to understand how to do this question, it's very, very simple. Just have to know that a percent of increase is how much you actually increased divided by your original amount. So let me just give you an example, class. If me, Mr. Quo, had $100 and I went from $100 to $120, well, wouldn't you say that my actual increase was $20 because you find the difference of the two? And then when you take the $20, you divide the 20 by the original amount of 100 to get your percentage increase, okay, which is a clean 20% increase. Okay, so using that knowledge, all you have to realize about percent increase is you just take the actual increase divided by the original amount. Well, it's funny because the actual increase is the walkway that we added, right? If we had the original pool, the swimming pool was 706.5. So I left that right here. The total area is 1256. So you just have to do 1256 minus 706.5, and you get the area of the walk, which is how much you increased your total area by. You then divide it by the swimming pool's original area, and I got 0.77 repeated, which means that the walkway added approximately 77% more area. Okay, I highly recommend that you try these problems. We could even change the problem numbers up a little bit, but ultimately, I thought this whole lesson was a review of what we've been learning. It's not really something new, right? We're just kind of listening to what they're asking, and we're just changing the numbers accordingly. Okay, if you have any questions, please leave a comment, and I'll see you next time. Thank you.